Blaze Recovery Team. I'm Pratika Kaur, and I had a privilege to work with an awesome set of team members, Maria, Yanli, Ian, Matt, Brian. Brian, can you go to the next slide? So to begin with our problem statement, wildfires are increasingly becoming prevalent in several parts of the world, especially in Alaska, which is warming at a rate which is double the world average, thus resulting in changes such as warmer winters, reduced summer ice, and increase in wildfires. Now, rising temperatures, prolonged droughts, changing precipitation patterns can cause rapid spread of these wildfires. These wildfires are not just immense threats to human life, wildlife, but they also add substantial amounts of carbon dioxide to the atmosphere. Thus, it is very important to predict future wildfires and what climatic conditions promote the ecological regeneration post wildfire. Hence, our group is here to propose an AI solution to predict fire occurrences in Alaska under variable climatic conditions and also to predict the time to forest regeneration post wildfire. I would like my colleague Matt to explain the research questions that would be focusing on.
Thank you. Given the information that Pratika has outlined about how climate is changing at a faster rate in Alaska, causing more wildfires, our specific research questions are how climatic changes, specifically changes in temperature, precipitation, and vapor pressure deficit, affect the probability of fire occurrence in boreal and tundra ecosystems, with our prediction being that fire probability increases in years following warmer and drier climates. And then second, what climatic conditions post-fire favor faster forest regeneration? And our prediction is that forest cover regenerates at a faster rate after fires under warmer and wetter climatic conditions. So I'll now hand this off to Yanli to chat about the model that we propose to use to answer these questions.
Thank you, Matt. So in terms of the methodologies, we plan to use the UNet, a convolutional neural network, to answer the questions we proposed. So for the first one, how does the climate predict the fire occurrence? We plan to have the input with a data cube of graded time series climate data like temperature, precipitation, and vapor pressure, and also the vegetation data, and go through this encoder and decoder network of UNet and give us a prediction of the spatial distribution of the fire occurrence. So with the fire occurrence, we can then go to the second question. So the fire occurrence we predicted in the first question now will be added as an input data to answer the second question. And through this another network, we can get the post-fire vegetation regeneration time predicted at Alaska. And here is just a schematic plot with, and we will introduce the data set we use.
Okay, so we're looking at three different data sets. One is fire, coming from the monitoring trends in burn severity. It covers 1984 to 2022 and has got over 1,000 polygons of substantial size. And climate data from TerraClimate, 1958 to 2019, monthly data, and then vegetation data, 1984 to the present from the Landsat. And here's some screenshots Maria's going to talk about.
So to know where to look first, we went to the International Arctic Research Center, and they have this graph here and to show us that 2004 was the highest level of wildfire, and in 2006 we chose that year because it's near and have a low rate of wildfires. So here in the left image, we can see that the fires in 2004 was much have much more than 2006. And then we start to dig in some climate variables like the vapor pressure on those years in January and June. So we can try to understand why that happened. So the intention is to pass through those years and temperature, air temperature and precipitation to understand more of this. The next one. So our expected outcomes and broader impact is the model that will predict the likelihood of fire occurrence under different climate scenarios can be used to predict fire occurrence under future climate and understanding of what climatic conditions promote faster forest regeneration post-fire to use to help inform restoration efforts of boreal and tundra ecosystems that have been affected by the fire at this time.
Okay, and finally, we're going to close with this flow diagram. So we have the first aim is going at the climate to the fire, and the second fire to vegetation. But this is really part of a larger system. Land is underlaying this, and then there are water considerations, including the North Pacific, as well as the snow cover, which we couldn't include at this point. So thank you very much. Stop screen sharing.
As a fire scientist, I'm so excited to see this. This is wonderful. Judges, do you have any questions?
I can go first. I just have comments. Like, I'd love to see this, particularly at the northern latitudes. I feel like there's been some work in the western US, but I haven't seen anything at the northern latitudes. So I love this, and this is one of my favorite topics. I also appreciate not only looking at fire and climate and fire influences, but the whole restoration and rebuilding. Did you think about any other land cover data sets to use to help drive besides Landsat that could help you tell more about the vegetation and the ecosystems?
I can say something, and Matt, maybe you can follow. So we did identify several other data sets. There were 3 different fire data sets, for instance. And but in the interest of time, we just focused on these for right now. Matt, you want to add?
I think that's exactly right, Brian. I think there are quite a variety of other data sets that we could use as land cover data in these models, but decided to focus only on Landsat for now.
Nachiketa?
Yeah, excellent, as Christian said. Do you have any plan to include the climate change model in your research in future, like CMIP 6 and others?
I think we're at early days on that. Maria, do you want to comment on that, or Matt?
Oh, yeah, sure. I think to train the model, we need more, not only more data, but more years and as I told, like precipitation, air temperature, and other variables. It's important. So yeah. Sure.
So one of our members is not here, Ian. He's on a plane right now, and he would certainly add substantial aspects to this. And Yan Li is an expert in AI, and so she would bring in from that perspective. But Ian in particular would be useful to help answer that question. It's not here.
So I think I'm next. Thank you for that excellent presentation. And on a really important topic. I was wondering if you see your model being able to eventually accommodate some things like fire history of particular sites or the actual vegetation burned, because my understanding is that, for example, the recovery of quaking aspen versus black spruce is going to be really different, depending on, you know, what's dominating the site that's burned and that type of thing. Is that something that you could include in addition to climate in your model?
Absolutely. Maybe Pratika or Matt want to speak to that?
I think that'd be fantastic to include in the model. Right now, we're looking at regeneration just in terms of greenness data, the NDVI data, I believe. So I think it's a fantastic suggestion that you have, Lori. We would just need to identify a data set that would tell us what specific vegetation is growing where.
Well, we have time for one more question or for the team to say anything else if you want to.
I can say we didn't particularly address TEK, traditional ecological knowledge. We did consider that early on, and there is a data set about that includes Alaska native lands. So we would see that as a future thing. I also want to mention that we had half men and half women, and we reflected at a few points at how the dynamic between men and women working together. So us men tend to speak up more, and so we worked at listening and being inclusive in that perspective within our team. Pratika, do you want to add to this point?
Sure. So I think I was the least experienced, but my team members really helped me to use my skill set, and then I learned a lot from them.
I am so happy to hear this, and thanks for sharing. One of the objectives of this hackathon was to build a community and an inclusive community. So thank you for making this happen. Really appreciate it. All right.